Good evening and welcome to today's session for the subject strategies for sustainable design. This is session 11 for week 11. Uh, this is what has been covered so far this week. These are three lectures that would have been covered this week. First lecture would have been on international conventions, international or global laws related to climate change and environmental management and sustainability, and the emerging technologies for sustainable design. Next lecture would have been on environmental laws, in which you would have studied various laws, both international and nationally applicable laws and related rules and regulations that form the basis or the regulatory basis of how sustainable development or sustainability is managed and promoted internationally, both internationally and within our country. Last lecture would have been on emerging technologies and their possible intervention in design. So, what are the new technologies that can be integrated into our design methodologies so that we can enable ourselves to design uh, in more innovative ways, design more efficiently, and design for sustainable development. So, this is what has been covered this week of lectures. Now, we'll go ahead and start with the questions. So, the first question today is the Copenhagen Accord was signed in which year? So, the Copenhagen Accord is basically a political agreement that emerged from the COP15 or the 15 Conference of Parties for uh, climate change, and which is conducted by the or under the United Nations Framework Convention on Climate Change, which is UNFCCC. It was held in Copenhagen, Denmark, in December 2009, and that is why uh, uh, the accord report, the political agreement that emerged from this convention is known as the Copenhagen Accord. So, while Copenhagen Accord was made, but this accord or this document or convention was not adopted as a formal treaty under the UNFCCC because of several defects or several shortcomings that document had, but it did represent a significant outcome of the negotiations under COP15, and it was sort of a groundwork or initial beginnings of developing a formal treaty through which COP15 or uh, uh, the the convention for UNFCCC could be adopted by different countries. So the key features that were there in the Copenhagen Accord were first of all setting emission reduction targets. So uh, what kind of targets should be achieved globally or by individual countries. Next would be what kind of financial assistance that is required and should be given to the developing countries in order for them to be able to further their steps in mitigating and adapting to climate change. So, uh, mechanisms for financial assistance to developed countries from to developing countries from developed countries were proposed or were made under this treaty. Next was uh, what voluntary mitigation actions the developed countries should take and should report. Again, that was a part of this accord. Then regulations or mechanisms for maintaining transparency and accountability in the country's reporting of their emission and mitigation actions. That was another component, and final component was what adaptation strategies or actions the countries are adopting to adapt to climate change, particularly in vulnerable countries and communities. That also should be taken into account and communicated. So these are all the components that were there in the Copenhagen Accord. But although the Copenhagen Accord laid the groundwork for future climate agreements, but it was not adopted as a formal treaty because of a lot of criticism that the Copenhagen Accord was not uh, legally binding in nature and also failed to set clear targets on what is the reduction targets, which countries are supposed to achieve what kind of targets, what is the time frame for adoption of the targets, etc. So all of this were a little vague, were not very clear, and that is why uh, uh, this Copenhagen Accord was perceived to be not a success in achieving more ambitious and legally binding outcome. So that is why it was not adopted formally. But it was signed in the year 2009 at the COP15. So that is the answer to this question. Another thing which you need to pay attention to or you can refer to while answering such questions is this timeline. So you would have seen this timeline in your lecture. So this is a timeline of United Nations Framework Conventions on climate change. So it tells you about the various conventions and what treaties or what um regulatory documents came out of different conventions or meetings or negotiations. So you can see here the starting of it is from, I think it's not very clear, but I think you can see it more clearly in your lectures. But I think it is 1988 when IPCC was established. Then first IPCC report came in 1990, and the original negotiations started from 1990 to 1992. And then in 1997, the UNFCCC was formed, and all the countries who committed to be a part of it, they signed the convention. And after that, UNFCCC came into force, and further negotiations and agreements were made, and Kyoto Protocol was the first commitment which came into being, and in 97 the Kyoto Protocol was signed, and after that various commitment periods of Kyoto Protocol which defined uh, or which allowed for countries to negotiate and then commit to uh, uh, whatever is proposed to be achieved, to commit to the targets that were set in the Kyoto Protocol. That commitment period started from there. Similarly, various other regulatory things like the Copenhagen Accord and later the new global treaty and further the Marrakesh Accords, these were further side. So if you want to get into the timeline of things, you should refer to this timeline that has been shared in the lectures. So I think it is pretty clear that the Copenhagen Accord was signed in the year 2009. Okay. So let's move on to the next question, which is which country withdrew from the Paris Agreement in 2019? And you have four options: China, United States of America, United Kingdom, and Canada. So more than one of these countries, I think, have withdrawn or opted out from the Paris Agreement. But in 2019, United States was the first country to have opted out from the Paris Agreement. Other countries followed suit and withdrew later, but the first country which opted out was the United States, and the United States opted out in 2019. So in 2019, under the administration of President Donald Trump, uh, the process of withdrawal from the Paris Agreement was initiated, and the withdrawal process or the withdrawal of USA took effect in November 2020, following the provisions of the agreement, which says that there is a 1 year notice period after the initial 3 year waiting period if you want to withdraw from the agreement. So this decision was made by the United States to withdraw from the Paris Agreement uh, because of the policies and views of the Trump administration regarding climate change and environmental regulation. What the Trump administration felt was that the regulations were not fair towards the developed countries. And also, President Trump expressed skepticism towards the scientific consensus on climate change, that climate change is occurring, and if we do not reduce our emissions, the global temperatures will rise by 1.5 degrees or 2 degrees, as we have visualized two scenarios. So President Trump expressed criticism or skepticism about the scientific consensus. He didn't agree to this, and also criticized that the Paris Agreement, it is unfair towards developed country, and United States is one of the developed countries. So because of this, the Trump administration argued that agreement placed undue financial burden on the United States and other disadvantaged American countries, uh, or sorry, another disadvantaged American industries, particularly fossil fuel and coal and oil industries, and claimed that the agreement allowed developing countries like China and India to still keep emitting in order for them to develop and continue to increase their emissions, while it required developed countries like the United States to make significant cuts. And also, as we saw earlier, there were provisions for the developed countries to financially aid the developing countries in mitigation and adaptation action. So again, this also placed a financial burden on the developed countries. So all of this was taken as unfair and undue by the US administration, and that is why in 2019 they withdrew from the Paris Agreement. Following the withdrawal of United States from the Paris Agreement, several other countries like New Zealand, Japan, Canada, they also withdrew from the agreement. However, United States was the first country to withdraw, and they withdrew in 2019, which this question is asking about. So I hope this is clear. Moving on to the next question, which is between which years were the Kyoto Protocol rules, or between which years were Kyoto Protocol rules led to development of the Marrakesh Accord. So this is basically asking that the Kyoto Protocol rules led to development of the Marrakesh Accords, but in during which year or during what period did this happen? So as we all know, that the Kyoto Protocol was adopted in 1997. So the Marrakesh Accords were developed after the Kyoto Protocol. So our answer would be from 1998, and also uh, uh, the Marrakesh Accords were finalized at COP7, or the seventh conference of parties in Marrakesh, Morocco, which was held in 2001. So according to this, we can assume, or we can interpret, that the Marrakesh Accord were developed between the year of 1998 and 2000. That is your answer. So as we saw earlier, uh, Copenhagen Accords were also made as rules or regulations for application of uh, 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 the climate change operationalization guidelines, but because there was a lot of criticism or shortcomings in the earlier accord, further detailed rules and guidelines needed to be made. So the Marrakesh Accord is one such guideline, and it was developed as a set of detailed rules and guidelines to operationalize the Kyoto Protocol. So uh, it covers various aspects, like first, the emission trading. This again we saw in the Copenhagen Accord. That only meant emission reduction and didn't talk about emission trading at all. So what emission trading did was it provided uh, an avenue for developed countries to trade the amount of emissions that they are making with another country which might not be making as many emissions. So in order to uh, uh, be able to make more emissions, uh, you can consider the amount of emissions you make as certain points, and you can only gather up to x amount of points, and after that you can't do more emissions or garner more points. But if another country, which is not very developed country, they are not even reaching x amount of points, you can trade with that country and take some of their points, and then provide some kind of financial assistance or financial aid to that country, and in this way the emissions, this is a very general idea of how the emissions trading can take place. So while the Copenhagen Accord only made provisions or made guidelines for emission reductions, Marrakesh Accord also provided aspects or regulations for emission tradings, how developed countries or countries with larger amount of emissions can trade with developing countries or countries which have lower amount of emissions. So that is one part. Another part is clean development mechanism. So setup of rules and regulations for what mechanism you can follow, that you, instead of having development which is not sustainable, which is riddled with a lot of emissions, a lot of greenhouse gases, you can have development which is clean. Next is joint implementation. So implementation of climate adaptation and mitigation projects uh, with both uh, uh, developed and developed countries, or bigger regions trying to implement uh, um, the aspects of adaptation or mitigations together. Next is the compliance mechanism. So this again was criticized about the Copenhagen Accord, that while Copenhagen Accord said that you need to uh, install adaptation and mitigation measures, it didn't say that how you can check if adaptation and mitigation measures are being installed, or if they're being taken care of. So Marrakesh Accord, what it did, that it provided a compliance mechanism and using that mechanism you can check whether the particular country is complying to the protocol or not. And last is the adaptation fund. So instead of just developed countries providing financial assistance to developing countries, adaptation funds, so provision for an adaptation fund was set up, which created a more formal mechanism of this kind of assistance provision from developed countries to developing countries for climate change adaptation and mitigation. So Marrakesh accordingly helped to clarify and streamline a lot of aspects related to the Kyoto Protocol and the Paris Agreement, enabling the countries to begin taking more concrete and actionable steps to reduce greenhouse gas emissions and to address climate change on a global scale. So this is what the Marrakesh Accord is, and as we saw, it started to be developed after the Kyoto Protocol, which is in 1998, and it was formally announced in 2001. So the period is from 1998 to 2001. So I hope that is clear. Moving on to the next question, which is among the four major economies of the world, which country had the lowest emission as per the World Research Institute data of 2014? We have four options: India, China, European Union, and the United States of America. So these are the four major economies of the world, and often these are the largest or most significant emitters of greenhouse gases. So this question is basically talking about or asking you to refer to the WRI data, and from that tell that in the year 2014 which country among these had the lowest emission. So I have linked the website of WRI where they uh, put up their emission data, or put up their inventory in which they record the emission data or display the emission data. So this is WRI's website. So you can see in this article, which was published in March 2023, again they are talking about the world's top 10 emitters, and you can see here in this chart as well, you can see which are the largest emitters. First, they have provided country wise or economy wise chart. You can see in this case China is the largest emitter, followed by United States and India and EU and Russia and so on, and also by uh, uh, sectors. So energy sector, electricity or heat sector, construction sector, transportation, agriculture, etc. By various sectors also it has provided that which sectors cause the most amount of emissions. But the question is asking, this data is not from 2014, this is from 2019, but the question is asking about 2014. So you can go on this interactive chart that they have, and they call it Climate Watch. So if you just click on through to here, it will take you to their online dashboard, which is called the Climate Watch. So if you go here, you can see they have several dashboards or several depictions of emissions and country profiles, etc. So what we need to see is the historical GHG emissions, because we want to see emissions from earlier years. So this is the dashboard for historical emissions, and we want to see the emission of the top emitters. So you can see this is the chart which shows the emission of the top emitters. So you can see China is the top emitter and emissions are rising continuously. Then you can see the emissions for United States, which have reduced. Uh, then for India, again India's emissions are increasing, but not as much as China's. So you can see emissions for different countries are there. What we are asked in the question is about the emissions in 2014. So if you go here, it will show you emissions of all the top emitters in 2014. So you can see here in 2014 the largest emitter is China, followed by the United States, followed by the European Union, and then followed by India. So you can see among these four top emitters, India has the lowest emissions in 2014. So let's come back to our question. So according to this, India is the lowest emitter according to the emission data of 2014. So I hope that is clear. I have linked this so you can go ahead and use this on your own. Okay, moving on to the next question, which is which organization has won the Nobel Prize? And you have IPCC, Greenpeace, World Wildlife Fund, and BRAC. So IPCC is basically a body under the auspice of United Nations, and although the organization didn't win the Nobel Prize as an organization on its own, but it shared the Nobel Peace Prize with former US Vice President Al Gore in 2007 for their efforts to build and disseminate knowledge about man-made climate change and to lay the foundations for the measures needed to counteract that change. So the answer for this is IPCC. So IPCC before 2007, we knew that climate change or global warming is occurring. We knew that the global temperature is increasing significantly since uh, uh, in in the past 100 200 years since the industrial revolution took place, but we were not sure what is causing this rise of global temperatures. But after IPCC's efforts in 2007, they published the report, which made it very clear that it is because of anthropogenic activities or human caused uh, greenhouse gas emissions, which is causing the global temperatures to rise. And this then laid down the foundations that we need to measure the climate change, that we need to measure what kind of emissions we are making, which emissions is coming from what sources, and how we can make reductions in these emissions and counteract the climate change that is already in action. So for this, the IPCC, with the US Vice President Al Gore, won the Nobel Prize in 2007. So the IPCC assessments were conducted by thousands of scientists from all around the world, and these assessments underwent rigorous peer review and played a crucial role in shaping the international climate policy. And the fourth assessment report, which came in 2007, this was the report that provided that compelling evidence that yes, human activities are the primary driver of the climate change that is occurring, and it also highlighted that what are the risks and potential impacts associated with continued greenhouse gas emissions. So the Nobel Prize raised the profile, also raised the profile of IPCC and its work, further underscoring or highlighting the urgency of addressing to climate change and for collaborative efforts on a global scale to mitigate the impacts of climate change. So I hope this is clear as well. IPCC, together with the former Vice President of US, Al Gore, uh, won the Nobel Prize or Nobel Peace Prize in 2007. Okay, moving on to the next question, which is the Air Act or the Air Prevention and Control Pollution Act of 1981 was amended in which year? So, for all of the national regulations or acts and regulations, you need to refer to this uh, list that has been given in your lectures. It shows the various years and key environmental laws and regulations which came out according to the particular time. So you can see here, in 1981, the Air Prevention and Control of Pollution Act uh, came into being, and it was amended through June 2010. So that is the answer to your question, that the act was amended in the year 2010. So the act basically was an act from the Parliament of India to control and prevent air pollution in India. So this was the first attempt ever made by the government of India to combat air pollution through formal regulations. And subject to certain aspects, this act was again uh, amended in the year 2010. So why do amendments take place? So amendments take place when we figure out, or when we find that the earlier enacted act or rules or regulations associated with that act are not relevant anymore, or have become irrelevant in the present context because of various reasons. Then we amend that particular act. So what can be the reasons? First can be the changing circumstance. So maybe societal, economic, and environmental conditions have changed over time, and because of that, it is necessary to update certain existing laws to address these emerging issues and challenges. So because of this, then amendment in an act can happen. Next is legal representation. So some of the court might interpret, after the enactment of the act, again some court might interpret that the provisions of a particular act, which was how it was initially planned or anticipated by the legislators, it's not functioning as it was initially anticipated. So for that, amendment can happen. So it can clarify any kind of ambiguous language, or rectify any unintended consequences that are happening because of those initially unanticipated aspects. Next is because of technological advancements. So many technological advancements can render existing or earlier laws obsolete or inadequate. So for that also, amendments in acts and laws and regulations can take place. Then because of international obligations, so countries may amend their laws to fulfill international obligations, like the Paris Agreement or other things like that. So Paris Agreement is an example of an international obligation which the countries agreed to comply with. So in order to fulfill those obligations, there can be amendment made to an existing law or regulation. And last is legal reform. So with time, amendments can come as part of broader legal reform. So if there is some legal reform seeking for more gender equality, or for some other aspect, so based on that, a broader legal reform can again affect and contribute to amendments happening in existing acts for improving their effectiveness and efficiency, or maybe even for fairness of the legal system. These are the various reasons that can cause uh, the existing acts to be inefficient or obsolete, and that is why amendments are introduced in the existing acts. So I hope this is clear. We move on to the next question. So the next question is, which of the following are not directly but indirectly linked to the integrated building technology system designer, or the IBTS? So there are four options: electrical engineers, architects, mason workers, and interior designers. So the IBTSD system is basically a system or a professional who is responsible for designing and implementing integrated systems within a building to optimize the performance or function of the building. So, why this is necessary, or why it is conceived? Because many a times when you are constructing or planning or designing a building, there is an intersection of various stakeholders or various functions. And in order to better plan or design or build or operate these buildings, you need for these various stakeholders and various functions to work in tandem. So for that, the integrated building technology system designer comes uh, uh, in. So what it does is that it works at the intersection of various disciplines like architecture, engineering, and technology to create a comprehensive solution that meets the needs of the buildings and the occupants. What it does is that it collaborates with multiple stakeholders to develop uh, an integrated design solution or integrated design solutions that can meet the project requirements. Also, it can meet the budget constraints, and also, if needed, sustainability goals. Uh, what it does is that it provides ongoing support for the system maintenance, troubleshooting, and optimization to ensure long-term performance and efficiency of the building system. And how it does is by integrating multiple components of the building system and collaborating with multiple stakeholders. So this question is basically talking about the various stakeholders that are connected or integrated within this system. So these are the stakeholders that are integrated within the system. So you have an architect, mechanical engineers, electrical engineers, construction managers, civil engineers, interior designers, the contractors, and the owner or the client. So these are the various stakeholders that form or are a part of this integrated building technology system. So you can see mason workers are not a part of this system, and that is why that is the correct answer, that it is not uh, directly linked, but to indirectly linked to this system. So it will either be linked through a construction manager or a contractor, or maybe through the client itself, but it is not directly linked to this system. It is always either managed by construction manager, or maybe by contractors, or maybe by the owner or the client itself. So I hope it is clear. Also, you can pay attention to the role of the IBTSD. It can encompass various aspects of building systems, and some of these include: first is building automation. So, if you want to automate various systems in the building, you again need to integrate them into one system, and in that case, this integrated building technology system designer comes into uh, com- comes very helpful. It helps in designing and integrating the building automation systems, which can control and monitor various building systems like the heating, ventilation, air conditioning, HVAC, or the lighting, or the security cameras, or surveillance, and also the control of access to the building or the building systems. So one is that. Another is the energy management system. So you can implement energy management system to monitor and manage the amount of energy that is being consumed within the building, and also if you learn from this data that what amount of energy is being used, and what amount is getting wasted, or how you can increase the efficiency, you can then use that data, or use the findings from that data to then evolve strategies which can help you to improve the efficiency of energy systems in the building. Another thing is information technology infrastructure, which can be integrated into the building. So, for designing and integrating IT infrastructure to support smart building technologies, you again need integrated building technology system design. So, I hope this is clear. So directly, mason workers are not directly linked to the system, but they are indirectly linked through other stakeholders. These are the stakeholders which are directly linked to the system and collaborate together with the integrated building technology system designer to work out design and efficiency improvement strategies. So moving on to the next question, which is the hazardous waste rules or the hazardous waste management and handling rules came into force in which year? So again, for this question, you need to consult this timeline of environmental laws. So you can see the hazardous waste management and handling rules came out in the year 1989. So that is the answer to this question. So the hazardous waste management and handling rules came out in 1989, and these are a set of rules or a set of regulations enacted by the Government of India under the EPA or the Environmental Protection Act of 1996. So these rules are aimed at effectively managing and handling hazardous wastes to prevent environmental pollution and to protect public health. So these rules have been amended several times to address emerging challenges and for improving hazardous waste management practices. And they basically provide a comprehensive regulatory framework for managing hazardous waste in India. And they aim to minimize environmental pollution and to protect public health and promote sustainable development. So I hope this is clear. Moving on to the next one. This question is which of the following is not a part of the operate section of BIM? You have options: renovation, documentation, operation and maintenance, and construction logistics. So a BIM or building information modeling is basically the foundation of digital transformation in architecture, engineering, and construction industry, or the AEC industry. So BIM is the process of creating and managing information for a built asset. So based on intelligent model and enabled by a cloud platform, uh, BIM integrates structured uh, multidisciplinary data to produce digital representation of the built asset throughout its lifestyle. So from starting from planning and design conception of the building to its final construction and operation of the built asset, it provides a digital representation of all stages of the building life cycle. What this helps you that How this helps you is uh, by connecting you through by connecting the teams that are working on the design and construction of the built asset, and through managing workflows, and uh, by distributing or uh, circulating data across the entire project lifecycle. So the BIM collects and manages data from the initial stage of designing and engineering to then the construction stage, and then through the final operation and maintenance stage as well. So using all this data and information about the buildings, you can realize better ways of working with the design, construction and operation stages, and for getting better outcomes while you go through these processes. So BIM is used for creating and uh, managing data during the design, construction, and operation processes, and it integrates multidisciplinary data to create detailed digital representations that can be managed in an open cloud platform for real-time collaboration. And using this, you can get greater visibility of your project, you can do better decision making, and you can also evolve more sustainable options and more cost-effective options uh, in the activities of your AEC project. So these are the four, or you can even say three, key processes that are related to BIM, or part of the BIM support system. First is planning, or you can say planning and design to be a same part of the same process. So planning is what comes before you try to build or uh, start to conceptualize the design. So you are informed by whatever is surrounding your building or whatever the ground reality is. You try to capture that ground reality and real world data to then generate context model of the existing buildings around you and the natural environment around you, and using that you can plan what you want from your design. Next is the design conception or design phase. So during this phase, you first go through conceptual design, and then some analysis, and then detailed design and documentation are performed during this stage. And this is the pre-construction stage when you design and plan out the details of the design, and uh, the pre-construction process begins using BIM data to inform uh, the scheduling and logistics that will be required to then build the project. Then comes the build stage. So during this phase, fabrication begins using BIM specifications. Uh, Project construction logistics are also shared with various stakeholders that are connected with the building process, and this helps to ensure optimum timing and efficiency in building the particular project. Then comes the operate stage. In this, the BIM data carries over to the operation and maintenance team of the finished project, and then this data or this kind of digital representation can be used to then uh, operate and maintain the building in a cost effective way. And at a later stage, if you even want to renovate and deconstruct the building, again the similar data and information insights about the building can then further help you visualize how you can go about doing that more efficiently. So these are the main processes of BI. So for each process there are several components. So for design components you have programming, conceptual design, and detailed design. So programming is first defining the project requirements, objectives, and constraints. So these then can help you analyze and simulate various scenarios to optimize space utilization in your building, for energy efficiency in your building, and for other performance criteria. So this is the first step that you take when conceptualizing or conceiving any kind of build asset. Then comes the conceptual design. So in this stage, you develop initial ideas and concept for the building project, and the BIM software aids you for the creation of both 2D and 3D models of the building to visualize and explore design options to enable the stakeholders to better understand what is the project's scope and requirements. Then comes the detailed design part. So in detailed design, after the conceptual design is done, the BIM software facilitates the creation of more refined 3D models with accurate dimensions, materials, and components, and uh, then you can get detailed specifications of the building system, structural elements, and other things which are necessary for the construction. And using this, then you can start preparing the scheduling and uh, uh, plan for building, which is the next stage. So build build components or building is the next stage of this process. And you have analysis, documentation, and fabrication, which are three parts of this process. So analysis is first part of this, in which BIM can be used for an analysis and simulation during the construction phase to first schedule and identify what will be the construction sequences, and also you can identify what potential conflicts might come. You can optimize the sequences, and you can also assess the impact of if you make such and such design change, or if you make changes in such and such schedule, what impact will it have on your cost, on your schedule, and on the performance of the building. So this is the analysis part of build. Then is the documentation. So BIM also facilitates the creation of detailed construction documentation, including the drawings, the schedules, and the specification that are followed through the building process. Last is fabrication. Fabrication is the last step in which BIM can help you to generate fabrication level models for building components such as structural steel, precast concrete, and NEP systems. And fabrication level models contain detailed information necessary for manufacturing and assembly of these components. So this is the last aspect of build stage in which BIM can assist. Then is the operate component of BIM. In this, first you have construction 4D or 5D. So it is operation management of the construction process, and it involves integration of 4D or 5D. So 4D, or the fourth dimension, is time, and 5D, the fifth dimension, is cost. So it then integrates the time and cost information into the model. So you can then visualize the construction sequences and construction activities, and also then you can evaluate the impact of certain changes on cost and duration of the construction. Then is the construction logistics. So BIM can help you optimize the construction logistics, including site layout planning, material handling, equipment placement, etc. So you can visualize all that, and which can help you optimize the construction and costs better. Then is the operation and maintenance. So in this BIM model contains comprehensive information about building components, equipment, and systems, which facilitates maintenance planning, asset tracking, and space management. Last is the renovation. So BIM, as I mentioned earlier, can also support renovation and retrofit projects by providing more accurate as-built documentation, and by identifying the existing conditions which need to be attended to, and by simulating proposed changes in the building. So these are all the components of BIM. So this question is talking about whether which of these are not part of operate section of BIM. So we saw here that documentation is part of build component, not operate component. The elements which are part of operate component are construction 4D, 5D, construction logistics, operation and maintenance, and renovation. So you can see documentation is not a part of the operate section. However, renovation, operation and maintenance, and construction logistics are all part of operate section of BIM. So I hope this is clear. Moving on to the next question. This is the last question for today, and this is: which of the following is incorrect for aluminium as a construction material? So you have options. First, that aluminum reflects up to 95% of the sunlight. Second is that using them can provide green building status as per LEED. And third is they are corrosion resistant. And last is none of the above. So you might have seen this graphic representation of the qualities of aluminum that can enable the construction of the modern skyscraper, or how aluminum has made the construction of the modern skyscraper possible because of its quality. So you can see first that aluminum building products are weatherproof and corrosion resistant. Uh, Also, that architects can design light structures with greater design flexibility, and aluminum's durability means that it can serve its function in a building for many decades to reduce maintenance costs. Also, that aluminum's exceptionally high strength to weight ratio makes it especially useful as a structural material, weighing up to 65% less than steel. Also, using aluminum in buildings can help them qualify for green building status for LEED, and coated aluminum roofs can reflect up to 95% of sunlight, dramatically lowering energy consumption in the building. Also, 50 to 85% is the range estimated for recycled content of all aluminum building products, including roof, slidings, curtain walls, window frames, facades, door frames, etc. Also, aluminum's contribution to energy savings during the life cycle of building is equivalent to hundreds of million barrels of crude oil usage annually. So, in that way, aluminum is a good choice for making buildings and even possibly skyscrapers. And you can see here that again the aspect that the question is talking about, that using them can provide green building status as per LEED. So that is true. Also, coated aluminum roofs can reflect up to 95% of the sunlight. Again, that is true. And for corrosion resistance, I think this will come here. So this is basically showing that also the aluminum building products are weatherproof and corrosion resistant. So again, that is also true. So none of these statements are incorrect. All of these are true for aluminum. So I hope this made sense. That was the last question for today. Thank you all for attending. Please go ahead if you have any further questions or any doubts.
Hello.
Yes.
I have a questions not for this course related. I just for the exam related. Because as of the notification, I know that the 27th is the exam date.
Mm-hmm.
So the hall ticket or any admit related any information is there with you, or because
I don't have any information. All the information regarding the hall ticket and your admit cards, that will be shared with you on your email only. So pay close attention to your email, check spams and
mm,
everything, because many a times the bulk messages go into your spam. So
because
mhm.
yeah, because for NPTEL we for exam registration is very earlier rather than other exam registration, because in SWAM there is a other institute exam also there. So
Mhm.
I came to know from one of colleagues that they recently just 1 month back or 10-15 days back they have registered, just a few days back, but our resistance were quite held on the initial of our course started.
Mhm.
So just I have a doubt that again we have to register again or
No,
anything.
you have, if you have registered once, I think that is okay. You
And
only need to
paid
register
also on
once.
that time.
Yes, yes, that is only once that you need to register for the exam,
Hmm. Hmm.
and you need to pay for the exam. Now you only need to see whether your hall ticket and details of when your exam and where your center is, all that will be communicated to you through your email only.
Okay. Okay.
Any other questions? Seema, Payal, do you have any questions?
No questions. Thank you.
So I think if there are no questions, I'll close the session for today. Thank you all for attending, and next week would be our last regular session. So next week, I think on 15th, let me check. On 16th, next week on 16th will be our last regular session. I have requested for an additional session on Thursday, which is the 18th. So that will be. Mm-hmm.
Yeah.
Yes.
No, nothing from my end.
Okay. So I was saying that 16th will be our last regular session. So that will be the session for week 12. And apart from that, on 18th, we'll have an additional session. So that will be sort of a revision session, or I'll just tell you what kind of questions to expect, how to go about solving them, and if you have any additional doubts from the entirety of the course content, you can go ahead and come with your questions, and we'll go about discussing your doubts then. So thank you all for attending today, and I'll see you again next week, 6 p.m. to 8 p.m. Thank you.
Thank you.
Thank you.